welcome back. Sorry for the delay. We'll now continue with Go Offensive Building Blocks by k0st.
Thanks. I will talk about offensive stuff, how you can build your own, let's say, C2 or whatever you needed for offensive operations, but in Go language, of course. Is there anybody here doing some offensive stuff? I don't ask if it's legal or illegal, only if it's offensive. No one? Oh, we have one. Okay, so that's it? Two. Wow. We have two. Okay, I think we have more, right? So, I guess you come to the mind when you want to, you have to develop your own tool, right? Either because of AV evasion or you need some specific feature or so on. So this is more about how usually I will develop, and that's it. A little bit about me. I'm Vlatko, or people know me as k0st. I'm CTO at Diverto, which is information security-based company. We have red and blue team and governance, risk and compliance, and so on and so on. I was leading red team for quite some time, but now have broader duties, and I've been in security for more than 20 years right now. And I've done a lot of open source tools and software, also as a contributor, but also as an author. So there was a lot of these things. So for example, if you've been using nmap NSC script to find log4j, probably you used my script. And of course, during all these years, I don't know, I gathered some of the certificates ranging from standard governance, risk and compliance to, of course, some of the security ones. Of course, I'm an enthusiast for martial arts, so I try to also cover all aspects of security. We will cover more than this, of course, hopefully, and I think we will enjoy. Of course, please ask questions. Every time I always like coming here because I never missed actually neither one from the first one, BalCCon, and I always find some new interesting ideas when you ask something or help me with something, so please continue to do so. So let's say there's also one other part, right? The other part is actually to use some existing tools, either open source or commercial. If you see on the market or from the news, even the criminals got lazy, right? They're not writing their own tool. They're trying to buy one, or steal one, or use the open source one if they are poor one, right? Or just starting, or criminal startup, right? So I will talk more about that other part, right? Where you actually try to write your own tool, or C2 or whatever you need for offensive. And the other thing is, yeah, that existing ones, if you're not so familiar with them and you just use the generics, most of these things can be easily fingerprinted and found, right? Because most of them are actually worldwide known and globally known. So this is one of the ways how to find it with server fingerprinting tool from the Salesforce JARM, right? There are, of course, the other ways and so on and so on. I will not waste time on these ways how to detect them, but actually I will spend more time about the Go. Anyone programming Go right now? Okay, we have a lot of people, great. But for the others which are not, this is the reasons why the Go is a good language actually to program something like that. First thing, of course, is portable. If I write something there, probably I could compile it on most of the platforms. The payload should be delivered, right? And the easiest thing is that it's at the same level, you can write some high-level language constructs and still use the low-level things. So that means even the C language. And on the end, you actually get, in most of the cases, static binary which you can run without any dependencies. So you never know where the payload might end up. So you don't know the environment, so you should have everything with you. And this is the perfect way for someone who is actually attacking the machine. He doesn't have to have any prerequisites. He can just lay down the tool where it is, right? And this is one of the examples how you can just easily write C, right? This is perfectly good in Golang, where you can actually just write the C code inside the comments. And you can actually decall it from the Go, and you can really write useful stuff here. Of course, there are some downsides if you use this. That means usually it depends on the C compiler or the platform if it will be supported. So yeah, it can be done, but it's not supportable anymore, right? So at least I try to avoid it. There are other ways how you can actually accomplish the same things. You have like the syscall library and so on, which you can actually use and call the syscall whatever it is, right? From the same operating system. So for those who are not familiar with all those, let's say, terminology, I'll just have this brief picture and telling that I will focus mostly on, let's say, exploitation part and post-exploitation, and not on vulnerability and how to actually get the first foothold there, right? So I'll spend more time on actually what after that, right? And as you know, we have vulnerability, the vulnerability is exploited, and then you have the payload, right? And this is actually that last step on which I will talk about. So if we go from the start and from the basic stuff, so we are everybody on the same level. At first times we had bind shellcode, right? It was like 20 years ago, even more, right? And everybody were running without firewall. Everybody was happy, having shell everywhere, and so on, right? This is actually the equivalent down there, right, with the netcat. I guess you know already something like this. And actually, if you look at the Go programming language, is actually the same. It's quite easy to actually get some easy shellcode on just using the pure Go programming language. So yeah, it's the basic one. You just set up one listener and then accept each connection and then redirect everything from the process to the connection you have. It's quite easy, and it doesn't have to be in assembly, right? And now it's portable. Okay, few years later, everybody learned how to use firewall, close the gaps, close the ports, right? And you couldn't connect directly now to the victim or to the attacking side, right? So the other thing is you just use right-reverse connection, where you actually initiate the connection from the victim to yourself. So that way is you are bypassing that first, let's say, ingress firewall. Of course, some language purists would say that you can actually get this one even smaller. Anybody played barrel golfing? So it's the discipline where you actually try to write shorter code, right? And in Perl, you can really write the short code. But in Golang, you can also write, right? So you can even write it in much less code. Let's say further, right? Everybody now learned, okay, we will close the egress filtering as well, right? We will not allow anyone connecting from the server to anywhere outside of the world, right? So we will just allow from that port where a web server is listening, right? Hopefully we are living in that world right now. Somewhere yes, somewhere no, right? And the solution here is actually to use some kind of injecting into web app, right? If it's PHP, it's much easier, right? You can just put somewhere some PHP file which will actually tunnel the connection and so on and so on. This is something which is standard like read George, if you ever use that tool. you can just put it somewhere where web app is sitting, or recompile the app if there is there, and then just add one additional endpoint which will point somewhere to the attacker, so attacker can call actually that endpoint and then tunnel everything via SOX 5, right? This is also one of the ways to get in, actually to get the shell back. And of course, we have, for example, DNS tunneling, which is usually used in scenarios where you actually do everything communication with the attacker with the DNS, right? There are downsides of this and advantages. Advantages, you actually talk with the DNS server of, let's see. So you're actually talking with the DNS server of the victim, and the victim is actually talking to some DNS server on the internet, and then on the end up, you actually talking with attackers. So that means you don't know where that ends up on the end, right? And it can change. This is something that you have different tools which probably maybe you used in the past, like Yodin, which is full TCP/IP over DNS, and so on and so on. And this is how you can actually bypass a lot of these traffic filtering rules, right? You have to allow the DNS to go through. And this is actually just pure example how you can actually easily write DNS tunneling using Go programming language. You actually just found the shell, right, which one you are using, and then you use one wonderful library, which is char shell, and you actually just redirect all the output there. And that's it, right? It's like 10 lines. Yeah, we can now go and talk about the other things like MTLS and so on, but the theory behind all of this is actually the same. We have the shell, we use some kind of a library for tunneling, and we actually get the shell back. So I don't want to waste more time there. I guess you know it's everything very similar. But I hear you cry, okay, but what about already written shellcode? I want to run my own shellcode. I have already machine-ready shellcode, I don't know, generated from a Metasploit, a Metapredator, or I want to run my CobbleStrike, I want to run whatever, right? Or maybe any other toolkit what you have, right? Even your own custom ones. Well, it can be easier, right? Of course, the shellcode must match architecture. Here, you don't have, you cannot choose, right, multi-platform. You have to write shellcode for each platform. But if you have the machine code ready one, right, then that's it, right? You just include one library, say, I want to run this shellcode, and here it goes. So that means you can run it in the byte array or as a base 64 encoded payload. Yeah, but I still want Metapredator, right? This is actually, funny thing is, that actually antiviruses usually catch the first stage of the Metapredator. And this one, actually, if you write it in pure Go or pure C, I implemented one, in, for example, in pure C, like called Nanomet, and you actually bypass a lot of those antiviruses. And this one is just implementation Go. It's pure Go implementation of first stage of Metapredator. And then we actually load the shell code, whatever it is, like TCP, HTTP, HTTPS, and so on. It's actually a lot of based on her shell from the syzdream. Of course, there are a lot of other libraries which I found, so you don't have to waste time. I actually spent quite some time actually looking at the libraries. At the first, like 3-4 years ago, there weren't so many libraries there. So we had to write our own, but now it's the situation quite changed. You have from the C extension, so this Brimstone, for example, library, actually they implemented that approach with using C extensions, right? So they actually call the shell code from the C. Have its own advantages, but on the other hand, it's not so portable, right? There are also like good Windows examples. that Go shellcode from Neon Dog. It's actually quite good because here you have how to inject shellcode on the Windows using almost any technique known currently in Golang. That means you can actually, I don't know, start from that basic ones, create remote thread to process hollowing, yada yada, and the other things. It's quite good. And it's actually quite good even for someone who is blue teamer. Right? Why? Because he can actually see what it can be detected and what's missing. So this is really takeaway for both red and blue teams. Of course, I like better approach where it is multi-platform and you are actually calling pure syscalls. So these last two are actually that examples. The other thing is actually how then include that shellcode, right? First thing is actually you can embed strings in Go, right? This is the thing where you don't have to change the source code each time you add some new shellcode. Okay, this is var shellcode, and this is the shellcode. There is actually a way with LD flags that you can actually, once you are building Go binary, you can actually change some variable. But it have to be the string type. You cannot change Boolean, integers, or whatever. And this is actually the good way how to actually inject the bytecode. Of course, disadvantage here is that you still need to build the binary again. Of course, if it's something bigger, there are things like Go embed, which is now in newer Go versions, so you don't have to do any of the other libraries, but it's actually including in the source code. And it's similar like Go bin data, where you create Go structures from the files. You actually get generated pure Go files, and then you compile with them together, and then you embed everything. But the other approach is actually stuff bin. It's similar to Windows resources, where you actually, after the compilation, you can add dynamically or remove some files from the executable. And can be quite useful, so you don't have to rebuild each time. And this is the example how you can actually embed, for example, files there. But this is for the build time in Go embed, right? And the problem is you have to rebuild each time. And let's go to the tunneling part, right? You have to communicate somehow. I was quite happy with HashiCorp Yamux library. It's a pure like a connection multiplexer. And if you need something like a reverse SOX5, I had implemented reverse SOX5 in Go. So you can actually get the SOX5. So you can actually, they connect to you, and then you can actually connect to them and do the pivoting stuff easily, right? And also like pivoting if you have to embed into the app. And of course, for DNS tunneling, I guess I already told you. So why Yamux is good? You can actually multiplex a lot of connections inside one single connection. So you don't have to do I don't know, handling of multiple connections. Maybe one is file transfer, the other one is, let's say, some kind of tunneling. And you can actually bypass the NAT as well. It's standard for, of course, NAT traversal. And this is usually how it looks like, right? The only difference is that you have currently one which is attacker server, which actually is now SOX5. And the victim is actually connecting to this server, and then this pretends to be SOX5 server for this attacker client. So how it's run, you actually run first the server, it's the same binary, everything is the same binary, and then of course you listen for connections from the outside, and on the victim you just connect with the password. So of course you are not sending any or getting some guests, unwanted guests for tunneling. Maybe sometimes that's a good approach. And of course, it's supporting like anti-element authentication, proxy, and so on and so on. And of course, you can set the user agent whatever you want, so you don't raise any big alarms. The other thing is DNS monitoring. Why it's important? Usually, it's good practice to put some strange domains to even which you don't connect to inside the binary and monitor for those DNS connections. Why? Because if somebody tries to resolve your domain, which is very strange, and you just use it unique for that binary, that means somebody is trying to analyze your binary. That means probably it's time to change your payload, right? And use something else. So it's typical blue team canary, right? You actually have way, except that you monitor hashes on Mirror's Total, on such portals and so on. The other thing is you just monitor for DNS requests. And if you put some unique DNS per target, per payload, and per machine, you can actually get quite an idea where it came from. And you have the tool which actually monitors all these domains. So if anybody gets something like resolving of that domain, that means it has to be changed. And one of the examples I can show, because I spent quite some time doing different C2s, is, for example, TTI2Web, which is accessible on my GitHub, and it's actually based on GOTI. And here you can actually expose any Unix command on the web, and you have like full TTI support with colors. So that means like you start the, let's say, TTI2Web, and if you connect with the browser, you can actually get everything like having on the console, and you can type commands inside the browser. Of course, the same thing is on the Windows, so it's multi-platform. So you can, for example, start PowerShell, and of course connect and run the commands. Here it's a bit problematic because of PTI support, because Windows 10 didn't have PTI support until Windows 10, and it's an update, so it took some quite time. And what's advantage, right? If you ever done some penetration testing and you had like a limited shell, you know how it is limited. Of course, you can always run those commands for improving to PTI mode of the shell, right? But here you get for free, and you actually get the shell inside the browser, so you can actually work as a team, because you can spawn more tabs and so on, and the whole team can actually work on the problem for escalating further. Of course, file transfer and download is supported, so you are not limited to only like having a single channel shell. And you have also reverse mode. It's similar as a SOX 5. So that means, again, the victim is connecting again to the attacker server, and then attacker only with the browser can connect to each shell and actually get the shell inside the browser. So how it looks like, you run the server, right, with the password, very strong password, of course. And this is on the victim side, and it gets the shell, right, and then you, as an attacker, run inside the browser the shell, and you have the shell, right? So it's quite more user-friendly than before. What that means? That means you can actually run, for example, Midnight Commander or any other command which have interactive commands. But we don't have to stop here, right? Since it's HTTP, we can apify everything, right? It's time that such shells get a once beautiful API, right? So you can actually like run post requests to execute some command there, and so on and so on. So it can be quite interesting to automatize every post exploitation action there. Also, things like exfiltration can be done by compressing on one side and decompressing on the other side, because actually this is not reading whole request, but streaming. So for example, the last request can actually, you can run the command to zip everything on the, or zip on that side, and tar unzip on the other side, easily and automatically. And the other thing is, yeah, you can run all those shells which I showed you with everything. So that means you can also get a Meterpreter shell, right? You just send enable on the agent that you want the shell, on what shell agent should connect to, and you just send what type of the payload. I just chose accept language because if it's some other ones, right, probably for some custom headers, probably it will raise alarms. So accept language looks quite good to actually say what kind of shell you want, right? And then, of course, you get a shell, and the rest, I guess, you know better than me. The other example is, of course, you can run JSON. So you can actually say, OK, run this shell code with this JSON, base64 encoded, and you get something like Meterpreter again, because this is the same Meterpreter payload, just as encoded base64. So yeah, it's similar. What I found it useful to actually, in such shells, to have for testing, for the container payloads, right? Like pods and everything, for example, inside the Kubernetes. Let's see what this container can do to other environment, right? To other pods, to same container, and so on. So this is quite actually good for pivoting tests and segmentation tests, because you can actually just add one single binary and have all these features and whistles, and you actually don't have problems with proxy balancers, HTTPS, reverse, and so on. And of course, I guess you listened, I hope you listened, like Sandra had yesterday a good talk about the incidents, and the incidents, there were a lot of files dropped last time, right? You heard like, I remember some proxying tool and so on and so on. Actually, everything is now moving towards, or actually moved everything now towards memory, right? So you don't want to have everything dropped on the disk and so on. So everything can be run actually from the memory. The Go binary, and also the payload which Go binary loads. And this would actually help a lot attacker to actually hide its presence, right? And this is just one of the examples which are quite good in actually archiving that state. So Donut is that standard Donut project, probably heard for it, and this is the actually implementation in pure Go. And I actually, it was quite some time ago, worked on a Go memory module with virus, and we actually had a quite good, until Donut appeared, success with running fileless payloads. And Go mem exec is quite good to actually run code from memory on the Unix and Linux side. Of course, there's also a problem how from the blue side you can actually reverse all that things and see what's happening, right? One of the good tips is that you actually have environment variables which you can actually turn on and see what's happening with the binary. So if attacker forgot to actually remove such things, you can actually get a lot of information inside. So yeah. And also, if you are looking for some kind of static analysis, like IDA Pro from version 7.6, actually have good support for Go. And you have like a Ghidra tool to actually get a good grasp what's going on with the Go binary. Now it's a good time, actually, for reversing, because earlier it was much harder for everyone to analyze malware. Of course, it's not impossible, but it was much harder. And Garble comes to the rescue in this stage, because it can help to actually obfuscate all those things, and it will make much harder for someone who is doing analysis. This is just example what, for example, Light and Tiny Mode is doing. It can actually remove a lot of those things which can be found in Go binary and turn off Go debug by default and so on and so on. And it's just like an install way. You can actually install the tool, and instead of running Go build, you just say Garble build, and everything is garbled. So it will take much more time for someone who is doing analysis on such binary. So yeah, Garble really looks good. So, in short, I think I covered everything from the red team side. So you can actually get the grasp of basic blocks, how to build it. I spent quite some time on looking at all those things, few years, and I think you can get idea even if you want to develop something like this in other language. It's quite good, and I just don't like spoon feeding, so I guess this is just enough that you get pointers how you can get going very quick. I guess even for the blue teamers, there's a lot of things which you can see which can be improved in detection, from tunneling to those executions and so on. So yeah, and thanks of course to BalCCon team who invited me, and to authors of different Go modules. I didn't write everything that is, sorry. And I used what was missing, I've written. I modified a lot of those things. So I tried to put everywhere credit. If I forgot, sorry. But I really tried to just quickly get grasp of everything and get it going there. Of course, to Virus, who actually had a talk about Go as a fancy language a few years back here on BalCCon. So yeah. Thank you. Voila. Do you have any questions? If you are shy, you can always ask me on the Twitter. Direct messages should be open, or I can open them. So feel free to ask questions. Oh.
So what of those don't work if you have like ASLR, write or execute and so on? What can we do as sysadmins to make your life miserable?
Well, this is the thing I actually mentioned. The idea, the question was, what can system administrator can be done to actually make life harder for someone who is attacking? I guess you know that already. Update, hardening, mostly hardening, and that means hardening on the network level, but as well as on the system level and on the application level. That usually makes things harder, because if I cannot do some syscall, if you already prevent some syscall, for example, in Docker container, right? You can use, there was talk yesterday, which talked a little bit about SecComp profiles and so on. So you can actually really, for example, disable a lot of syscalls which your application doesn't use, and then you can make it harder. I have to guess which syscalls are not there, and I have to write it differently, right? So hardening is one of the best ways for most of these things. Of course, there are other things which I didn't mention here, for example, like how to get initial foothold and so on. I was just focusing on those, running the payloads and everything. So you get like, I don't know, some critical security controls, like 20 critical security controls and follow that things. from the global point of view. And from this side, yeah, a lot of things. Hard to mention everything. That there is like a lot of like you have like a Linux security how to and so on and so on. So it's from the very beginning, from the system level, hardware level. Vlada mentioned it, and from the application level. But you have to not you cannot forget something, because then again you have the problem, right? That's why it's easier for attacker. They need to only find one hole, and defender have to close everyone, right? Every hole that you can find. So it's not easy economics. Sorry, it's hard to actually compress everything and what can be done. Any other questions?
So here.
Okay.
Yeah, is it possible to include inline assembly into Go?
Yeah, I was actually looking at such things, and it was quite painful. And mostly I didn't want it to go that way, because it's hard and portable. It's not portable. For example, that's why I wanted first to actually have like a support for alphanumeric shellcode as well, but on the end I had to like make a call like call AAX and or any other register where I actually configure the shellcode, right? But then I had to do like a lot of prerequisites and so on, and I said, okay, I can just encode it with any other encoding which Go supports, and alphanumeric shellcode you get like compression is not good, right? You get it first, so it's not so. You can, but it's hard, and I don't know if you want to go that way, because most of the things you can really do with the syscalls, and if not, with the C. So yeah. Of course, there is other way. You can always like with CGO, you can actually say and do the like standard linking stuff, and you can specify your own options and so on and so on. And then you can just include one of the object files, and then you can actually do whatever you want. So that's one of the ways. To answer your question, if you just really want it, but it's really painful. I wouldn't recommend it at all. Thanks for your question. Anyone else? Okay, I guess I managed to make everyone understand or don't understand at all. So thank you.